this one is June 2022, Unit 6. In the first question, a student investigated heating of a liquid using an apparatus shown. There's a steam generator is there, and then the nozzle is there in the liquid, and the thermometer is placed. The control tab adjusts the rate of a flow of a steam from a nozzle, and the steam heats the liquid in a beaker. Maybe you have seen in the coffee makers, this is how it is done. Student use a kitchen thermometer. The thermometer scales are shown. As you can see, this is a scale of a thermometer. Outside is in degree centigrade and inside is in Fahrenheit. State the resolution of the thermometer in degree centigrade. When we say resolution, means like the smallest value which it can record. So in degree centigrade, like you can see, like this is 0 and then one line and then 10 is there. So this line is 5. So the difference between the marking is 5 degrees. So the resolution of the scale is equals to 5 degrees. Because resolution of a thermometer here refers to like the smallest value which it can record. So smallest value which it can record, that is equals to 5 degrees. Next is the student heated the liquid and he started a stopwatch and recorded the temperature of a liquid. He recorded the time at a fixed interval of a temperature as a temperature increase. Explain why this method was a better than starting a stopwatch and recording a temperature as a fixed time interval. So why this method is if better than the starting the stopwatch and recording like temperature after every 10 second or 15 second. So because what will be the advantage? In this case, as you can see, the resolution of a stopwatch is better than the resolution of a thermometer. Like error in thermometer or the smallest value with thermometer can record is 5 degrees as compared to smallest value which can be recorded by using a stopwatch, which will be a smaller than 5 degrees, like 5. So therefore it will have a smaller percentage uncertainty. Because what is a percentage uncertainty? The percentage uncertainty is uncertainty divided by value recorded into 100. What is the student heated the liquid and he started a stopwatch and record the temperature of a liquid. And he record the time at a fixed interval of a temperature. Like he recorded when a temperature changes from say 90 to 85, how much time it will take. So why use reading a value with a stopwatch is a better thing rather than reading a thermometer. What is the advantage? Because the percentage uncertainty is uncertainty divided by value recorded into 100. As we are using a stopwatch will have a smaller uncertainty, so it will have a smaller percentage uncertainty. So the uncertainty of the stopwatch is smaller than the thermometer, which reduce the percentage uncertainty. So using a stopwatch, as a stopwatch will have a smaller uncertainty or a least count, that will reduce the percentage uncertainty in the readings. The student repeated the investigation with a different liquid. He started timing at the same initial temperature. State another control variable that would allow him to compare the specific heat capacities of the two liquids. So if you want to compare the specific heat capacity, what are the other parameters we should keep constant? Like for a fair comparison, we should take equal mass of the liquid, the two liquids, or we should take, because equal volume of the two liquids, or we can also mention as we are supplying heat energy by using a steam generator, so the position of the nozzle, the amount of the steam enter to heat up, the rate at which the steam enter the liquid, that should be constant. So many factors are there. Any one you can mention about the mass or the rate of steam flow or the position of the nozzle. The student plots a graph of a temperature against the time for the first liquid. Sketch on the graph the line with a greater specific heat capacity. If we have a greater specific heat capacity, then the temperature change will be smaller. And they already mentioned that we start both liquids with the same starting temperature. We have the formula C is equals to E is equals to Cm delta T. Energy is equals to specific heat into mass into temperature change. So if we are supplying the same amount of energy, we keep the same mass. So what is the relation between temperature change and the specific heat capacity? The higher specific heat capacity means a smaller change in temperature. We start both liquids with the same initial temperature. So we'll start with the same initial temperature. But because the second liquid is having a greater specific heat capacity, so it should have a lower temperature change in the same time interval. So your line, it will be a bit curved and it should be below the original. Another student performed the investigation using a thermometer temperature probe connected to a data logger. You have to learn these advantages. What are the advantage of a data logger? Because first thing, we have to measure a time and temperature, two variables we have to measure. So the data logger, whenever simultaneous readings have to be taken, then data logger is the best choice. So it can measure the simultaneous temperature and time, and in that case, when a data logger is used, then it will have a smaller least count in temperature, and it can record more readings in a short time interval. So first advantage, it can record, in this case, time and temperature simultaneously. And the second advantage, it can record greater set of values in short interval. That another thing, it will have a smaller resolution, so it can record the value easily. The next question, question 2 from this is June 2022 paper. Two identical pendulums are linked together using a rubber band as shown. So you can see a rubber band is there, a spring L is there, and this is a rubber band. Identical pendulums are there. One pendulum is set in motion, the amplitude of oscillation of this pendulum decreases to zero as a rubber band transfer energy to other pendulum, which oscillate with the increasing amplitude. So what happened? The first pendulum start to slow down and the second pendulum start to move. The energy is continuously transferred between the two pendulums, so their oscillation alternated increase and decrease. Like, for example, we set up this pendulum in vibration. So first this is vibrating, and this gradually its vibration will slow down, and which transfer energy to the second pendulum, its vibration start to increase. Once this pendulum slow down or stop vibrating, the second pendulum now slow down and transfer energy to the first, and this will continue, but it will not continue to infinite time, as there is always some energy loss due to a friction, and some of the energy will be stored in the rubber band as well. So it will not last vibration for infinite time. There will be a finite time. The time for amplitude of one pendulum to change from zero to the maximum and then back to zero again is P. So P is a time, like first its amplitude changes from zero to maximum and then from maximum to zero again. Like first it is zero, then it start to vibrate and reach a maximum and then start to slow down and again zero. That is the total time which is given by P. It is suggested that the relation between P and the vertical distance L between a metal rod and a rubber band is given by this formula, where A and B are the constants. Devise a plan to test the validity of this relation using a graphical method. First thing, as you can see this equation, we have to transform this equation it is written P is equals to A, L, and B. So whenever power is there, what we do, we take ln both sides. So we'll take ln P is equals to ln A and LB. Now, whenever two quantities are multiplied in ln, we write them as addition. So it will be ln A plus ln B. So this we'll write as ln A plus ln LB and ln P. Then whenever in ln, if one of the quantities are powered like a raised to power x, so we write x ln A. Like this power will be the coefficient now. So we can say ln P is equals to ln A plus B ln L. We want the two quantities, that vertical distance is there and the P is the time. So these are the two, A and B are the constant value. So if I rearrange this equation, I can say ln P is equals to B ln L plus ln A. Now, when I compare with the equation of a straight line using a formula y is equals to mx plus c. So on y-axis, if I plot ln p, on x-axis, if I plot ln L, the gradient, because the gradient will be b, it means it will must be a straight line. But this straight line will not pass through origin because there's a y-intercept. So there must be a straight line, but it will have a y-intercept, positive or negative y-intercept. So this should be the graph. So we have to devise an experiment, like how we should do this experiment to work out the value for to justify this relation. First thing, the quantities which we have to measure L. So how we can measure L? As we have to measure L, so how we can measure L? We can use a meter rule or a meter scale and measure this L. And when the pendulum start vibrate, because P is a time for a pendulum to reach a maximum value from 0 to maximum and then return back to 0. So what we'll do, we'll start a timer and record the time for a pendulum to vibrate to its like maximum value and then return to 0 amplitude. And then we'll repeat the experiment with different values of L, like 3 values or 5 values minimum we should, and then take ln L and ln P and use the equation, plot a graph between ln P and ln L, and the gradient of this graph will be equal to B. So this is how you devise the experiment, because the question is devise the experiment means how you plan this experiment or do this experiment. So first what we'll do, L is a length and T is actually a time. So first thing, we'll measure the length L by using a meter rule. And when you devise any experiment, it's important that you mention the sources of errors and the precautions. So measure the length L by using a meter rule or a meter scale. Then we should look perpendicular and avoid a parallax error. Look perpendicular to avoid a parallax error. And you can also use a set square. Then start the timer. To record time for pendulum. Then repeat the experiment. With 5 minimum, you should mention like 5 different values of L. And plot a graph. between ln p on y-axis and ln L on x-axis. So these are the points you should mention. The distribution of the marks, like how you will score the marks, the distribution. First thing when you mention and mentioning a repetition and repeat experiment and take average. So first thing, when you mention using a meter rule or a meter scale, that will score 1 mark. Look perpendicular, avoid a parallax error, and using a set square, then start the timer and repeating experiment, taking an average and plotting a graph. And even here, record the time for a pendulum. This explain, you have to explain it fully, like record a time for like 20 times or 30 and then divide by the number of the cycle to take an average. Like elaborate this point as well. That's we usually do for like finding a time period of a simple pendulum. A student recorded the motion of a pendulum using a video camera. State how this may improve the measurement. Look how it will improve the measurement. If we are using a video camera, the one advantage, it can be playback. Or because in a real time, it will be difficult to identify the exact moment that when this pendulum has just stopped vibrating. So it will be difficult to judge the exact moment that the pendulum stopped vibrating. So using a video camera, we can play back and like we can observe its motion easily as we can play back, and it will give a more reliable result as it can be played in a slow motion. So it will reduce in real time. It will be difficult to judge the exact moment of pendulum stop moving. So using a camera, we can play back or use slow motion, which reduce the effect of reaction time. So these are 2 questions remaining. We will do in the next session, the question 1 and 2 from June 2022 paper.